Hi everyone, welcome to this edition of the Hangout on Air, and we're delighted to have Baker Franke and Brook Osborne with us from code.org. So, longtime friends and deeply involved in CS principles for many years, so I'm sure you're going to learn a lot of cool things and see some new tools and hear about what code.org has planned. So we just released Unit 4.1, so please make sure you're checking that out, and also check out the talk this morning with Jeff Kramer on abstraction. And we'll be able to compile a link of all the resources and even the YouTube video again of Baker and Brook's talk. So Baker and Brook, you want to go ahead and take off and just maybe say a few things about what you've been doing with code.org and any other direction that you'd like to go?
Absolutely, yeah. First of all, thank you so much for having us, Jeff. It's great to be here again. I wanted to just give an overview of what we're going to talk about today so you know what to expect, and let you know that everything you see right now you're going to have access to after the fact. So don't worry about trying to grab links or anything like that. We'll share it all with you later on. So we're going to start by giving you a little bit of an overview of the course, giving you a status update of where we are with our curriculum development, and then also sort of diving into the teaching materials that we're developing. I know that Jeff has shared some of the tools that we've made with you already, so we're going to look at those tools in the context of the teaching materials that come along with them. And then we're going to check out more tools that you haven't seen yet, share links to all of this stuff, and then leave time at the end to answer any questions. So I know you might have access to some of this stuff already and you might want to follow along, but I would encourage you to not get distracted off playing with the tools yourself. You can do that later on. We'll share everything with you, but for now, let's just check stuff out and we'll run through some demos. You can see everything on code.org/CSP later on, but I'm going to turn it over to Baker, and he is going to give you an overview of the course.
Hi, everyone. You can't see me because my face is blocked by this presentation, but thank you again for joining. You can find out about our course if you can remember. Code.org CSP, you can know the address to get to our site to find our resources there. So a quick overview of our course. There are technically 5 units of study. The first 4 are sort of the core learning units. That 5th unit, called performance tasks, we hold out there because the College Board, the CS Principles Framework, requires that you devote a certain number of class hours for students to do the performance tasks. So we just want to make sure it's in the schedule so we don't forget about it, even though students might be working on the performance tasks throughout the course. So our first unit, called Digital Information, is really about the digital representation of information, and not only is it concerned with how binary and bits are used to represent information, but also how those bits get from one place to another. Because one exciting thing about the CS Principles course and framework is that it acknowledges that the internet exists, unlike, for example, APCSA. So the internet is what makes CS Principles unique. So after that first unit, we move on to Unit 2, where we study the internet a little more formally. We learn about the internet protocol stack and the different ways that the internet was built and structured. We also talk about security and privacy here, and techniques of encryption and encoding things, so that things that play into your life as a digital citizen and your security and safety using the internet. Our third unit is the programming unit, and we're going to talk today a little bit about how we teach programming and the tool that code.org just released to help us with that, called Applab. The programming unit, we program in a language, the JavaScript language, and it assumes no prior knowledge about programming before starting. With JavaScript, students are creating they're actually web applications, but they're often built for mobile contexts. But they make little web applications, and so sort of the model of programming is event-driven programming, if you know what that means. Our fourth unit, we call the data unit. Students will continue to program, still be making some apps, but the focus here is on data. So our programming tool allows students to create a backend database that's pretty easy to use, and so they'll make little apps that collect data, which allow you to ask interesting questions about, okay, so you can make an app that collects data now. Is that legal? Like, what kind of implications are there that any person off the street can make an app that might collect data about a person? And so there's an ongoing project in that data unit where students make an app that collects data, and they analyze that data in various ways. So that's a quick overview of the course structure. Our goal in constructing our course really was to provide a really rich set of resources for teachers to use to teach this course, almost even regardless of whether or not you want to use our lesson plans. So we wanted to provide so many resources that you couldn't really even use them all, and kind of drinking from the fire hose. So our teaching materials include daily lesson plans for all the lessons, teacher-facing support videos. So we have a lot of lessons that are unplugged lessons, and sometimes it's hard when you read the description of the lesson to know like how the room is set up or what you can expect from kids. And so we've made videos that show those lessons in action, so you can get some, when you're preparing for those lessons, you can get some expectation of what you should be seeing. So we have student and teacher-facing concept videos. So a concept video is something that is generally useful for CS knowledge that you should have coming out of CS principles. So these are like high production value videos where we frequently will get people who are working in the industry, or even, I call them computer science celebrities, talking about the things that they made. So for example, we have a whole series on the internet that features Vint Cerf, the guy who invented all the stuff that you study in, in CS principles. We also have student-facing activity guides, so things that students use to guide them through the lessons, and learning tools, digital learning tools that aren't just programming. So we've spent a lot of time and effort making tools to learn computing concepts beyond, or I should say, other than programming, and we're going to show you one of them today. Jeff told us that you guys have seen the text compression tool and the pixelation tool, so those are examples of tools like that. I just gave you the tour. Here's a screen cap of what a lesson plan looks like. I guess this proves that it exists. We also have teaching tips video. So this is an example of what a teaching tips video might look like. Shows teacher Brook in a classroom with students, and shows sort of students working together and what you would expect to see. Concept videos, these are the more high production value videos. This one happens to be about the internet and the sort of the physical internet, how bits are actually transmitted from using wires, cables, and Wi-Fi. Here it is. This is the text compression tool, which you have seen. The pixelation tool, which you have also seen. I think maybe I'm going to kick it to Brook here to take you on a tour of Code Studio, but we're going to look at those tools, text compression and pixelation, the ones that you have seen, in the context of our course delivery platform, which is called Code Studio. So for that, I'm going to kick it to Brook, unless she shakes her head vigorously at me.
No, that sounds great. Can you also physically click that picture that you're looking at right now? Oh, yeah. And that should take you to, awesome. All right, actually, can you maximize that? Great. So this is the Code Studio environment for Unit 1. So our whole course is available through Code Studio. Baker is logged in right now as a teacher, so his view is slightly different than your student's view will be. You might notice there's something there that says View Lesson Plan at the bottom of every stage. So here is where your students are going to access all of the digital learning tools. They're going to access all of their sort of level progressions and student activities, and you will have access to lesson plans, and those lesson plans are hidden from your students. So Baker, if you can scroll down to stage 13 and stage 14, which is where those tools that, that you've already seen, text compression and the pixelation widget, live down sort of at the bottom of this unit. We want to look a little bit about how those tools work in context. So the text compression tool happens in lesson 13, and Baker, if you can click on level 1. So level 1 of all of these stages, this is sort of the student-facing lesson plan. We have a review of what happens in the activity, all of the important vocabulary, and links to any and all handouts or worksheets that you might choose to print out, or you might choose to just have your students access digitally right here at the bottom under the resources section. If you click continue here, this will take you into the tool itself. Every time we introduce a new tool, there is a tutorial video that explains to students and to teachers as well how to actually use the tool, and often will connect directly back to the lesson that's related to the use of that tool. And Baker, if you want to go ahead and dismiss this video. So you've seen this tool before, so this ought to look familiar. It looks a little weird because we're super zoomed in right now. But this tool is being used by students in the context of an activity guide that they would have either accessed on level 1 or you would have printed out for them. If you play around a little bit, you can get compression. Baker right now has a 29% compression rate, so he's doing pretty well. See if you can improve it. 34%. And if you've used this tool, you have an idea of how it works, but if you've not used it before, the idea is you are compressing the text on the left by generating a dictionary, by identifying the repeated or the things that have patterns across the body, and that's what Baker's typing into the dictionary over there. After your students have gone through this activity, they can continue on to later levels on the stage, where you'll always find we've built in written opportunities for your students to practice their writing. And the reason we've done that is because the students are all going to have to do writing for the performance tasks, which the College Board have made part of the AP score. So we give students opportunities to reflect on what they're doing, think about their process, and actually practice writing. So you are free to and welcome to use these resources however you want. We don't expect that you're going to have your kids answer all these questions. These might be discussion prompts for you, or you might have them actually come in and type things out. But we want them to be here for you as a resource. So, Baker, do you actually want to click into the lesson plan for this?
Brooke, were we going to actually do the pixelation lesson plan?
Sure, go for that one.
I'll do the color one.
So every lesson plan has the same general structure, which, can you zoom in a little bit? Is that possible?
Getting there.
Okay, great. So the first page of every lesson plan looks exactly like what you see right here. We have the same basic structure throughout every lesson plan document, and we have a first page that acts sort of as your guide or your overview to the whole lesson. So on this first page, you will always find testable student objectives that you can use to make sure your students are understanding the concepts. So that's a good formative assessment tool for you. We also have resources on the right-hand side, and that includes those concept videos that Baker was talking about before, as well as the teacher-facing resources and supports like a teaching tips video. We'll include links over here to any of the worksheets you might want to use with your students, as well as assessments, rubrics, things like that. So basically, the right column on the first page of a lesson plan is your one-stop shop for everything you might need for that lesson, including a list of any materials you would need in class. As you keep going through the document, you've got your teaching guide that really breaks down every activity and tells you step by step the things that need to be covered. And this isn't written like a script. It's not like we expect you to stand up and just read off what's there, but it is very detailed, and we do that because we want you to understand and we want to be really clear about what students should be getting out of the activity. Every lesson also has examples of extended learning, which are opportunities for students who either finish quickly quickly and need more work to do, or if you're in a situation where you need to give homework. Those are good homework opportunities. And then there are also assessment questions, which again, we envision as formative assessment tools for you to use with your students to check their understanding and see where you might need to revisit concepts or topics. And then at the bottom of every lesson, you will find mapping to learning objectives. So it's super important that we're covering all the learning objectives in the curriculum framework. And you will notice that many of these lessons cover many different learning objectives, and that's because they do cut across lots of the big ideas. We also have these handy teaching tips that are built into the lessons themselves. So this box you see right here is an example of a teaching tip, and that's something where you either might want to call this out with your students, or it might be a strategy for dealing with a particular portion of an activity or a particular concept with your kids. So lots of really rich material there. Another tool that we use that we want to introduce to you today that you haven't seen before is called the Internet Simulator widget. So we use this tool in a couple of different places in the course. We actually start using it in Unit 1, and it builds layers upon layers until eventually we have a very robust and complicated version of an Internet Simulator that really does model what happens on the Internet.
Right.
So, do you want to describe that a little?
Sure. So the resources that you guys have seen and that Brook just described are all in our first unit, and our second unit hasn't really seen much daylight so far. So we thought we'd show you some things that are in there. When we talk about the internet in this class, we typically ask students to solve a problem that people who invented the internet had to solve. And the way that students solve this problem is by using, we keep mentioning this tool, our internet simulator. And even back in Unit 1, we used this tool to solve the initial problem of how to send bits, a single bit from one place to another, and how to coordinate two parties with a protocol. Our internet simulator acts very much like the internet itself in that our lessons build layers upon layers upon layers of protocols. And so once students have solved sort of the hardware problem of how do you physically send a bit from one place to another, they don't have to solve that problem anymore. And we add another layer that they now have to describe what the meaning of those bits is that they're sending back and forth. Do they mean numbers? Do they mean text? Do they mean images? And that's all in Unit 1. When we get to Unit 2, we're now talking about more sophisticated communication protocols. So we are now going to do the thing you should never do in a Hangout, which is the live demo, and to show you something, a version of this tool that we use very early on. So who's going to screen share on this?
I can. I see you floating in the background. I think.
Oh, I have it open in the window already. So Jeff, Brook, and I are going to attempt to do this. I just need to get my act together.
So while Baker is joining, you can see right now Jeff and I are connected on a single wire on a version of the Internet Simulator where we'll actually all be able to connect to one another. And this is a mode that we call broadcast mode.
All right. Sorry, Brook. This isn't This isn't broadcast. See, I told you. Never attempt the live demo.
Sure isn't.
Well,
I can set this up. Do you want to go ahead, Baker, and talk about where NetSim goes from here, and I will set up the correct version, and we can all join that?
Sure.
Okay.
So the Internet Simulator, which we're about to demo for you, after people have been connected by a single wire, then we have multiple people attach themselves to the same wire. And so you can see all the traffic going back and forth, and you need to invent a way to address messages. And once you know how to address messages, we introduce routers into the simulation. And so with a more formal IP address structure, and in fact, the nice thing or the interesting thing about our internet simulator tool is that you cannot use it alone. Well, you can, but it's cumbersome. It is designed to be used in a classroom with students to solve internet-y type problems. So when we introduce the routers, your entire class can get connected in this internet simulator to different routers and send messages back and forth once they figure out one of their classmates' IP address, which they can do by sending a message to a DNS server that's also part of the simulator. And then everybody in the whole class has the ability to see all of the traffic that's going through the routing tables as well, which introduce interesting questions like, why did my packet that I sent to my friend take a different path each time it went there, right? So we simulate packets taking different paths to their destination, or different numbers of hops. And you can also begin to ask interesting security questions like, who owns the routers, and what can they see? And it introduces your motivation to start to have secure, more secure transactions. All right.
All right, so Baker stalled for exactly the right amount of time, which is great. And I'm going to share now. And this is the version where all three of us are, in fact, connected to one another. So you can see on my screen here, I've got up at the top a section here that says it's my received messages, a section that says it's my sent messages, and then a section where I can actually type things out. And I got something that says, hey, but it turns out I have no idea who this just came from. So that's because we are we are in a mode called broadcast mode. So this is a mode where everyone sees anything that's sent across the wire, but we don't know who it comes from by default. So this is used to motivate the need for addressing, and which addressing is something that they're going to deal with in the next layer that they see here.
So as Brook is typing, Brook, do you also want to click on the My Device tab to show what people can see with that?
Absolutely. So we can toggle on binary and ASCII, and this is an important part of Unit 1 that Baker was talking about before, where we talk a lot about the digital representation of information. So students are going to get very comfortable with the idea of binary as another way to encode or represent information. And ASCII is just, the way we're used to seeing it, but it's not the only way that information like words can be represented. So we see here that when we type a message, and I can type it in ASCII or binary, when I type each letter, if I have binary toggled on, I can see the corresponding binary representation. If I start typing binary down here, then I'm going to see the ASCII representation.
And that's a feature, or the Internet Simulator, this one you can only toggle binary and ASCII, but in previous versions, or the Internet Simulator is configurable to actually allow you to see the encoding in multiple ways. So when it's on fully, you can see the decimal, the hex, the binary, the ASCII of everything. And students send messages in different formats at different times. So in the lesson where students are first introduced to this, why do students need to invent an addressing scheme? Because they're attempting to play Battleship, a game of Battleship against multiple other people at the same time. So you'll have 3 or 4 people all connected together, and each of the 3 people is trying to play a game of Battleship against each of the other 3 people, individual games simultaneously. And it quickly becomes chaos, because it's hard to figure out who messages are supposed to go to, both the call and the response. And it's really fun and can be kind of raucous. And we use that to not only motivate the need for addressing, but also to motivate the need for a concise, consistent protocol or way for sending like battleship type messages from one place to another. And that leads into a lesson about packets and packet structure, and being able to have an expected structure for the information that's going back and forth really facilitates communication. So that's NetSim. Brooke, should we move on to the next thing?
Absolutely. So students are going to use the Internet Simulator in all of these various states and layering on top of itself and increasing in complexity through Units 1 and 2. And at the end of Unit 2, students are going to transition from thinking about the Internet and how it functions to now thinking about how we can use the Internet and all of these protocols we've been building to actually display some information. So we start programming. And in our programming unit, we use a tool called Applab. And Baker, do you have...
I'm getting there.
Perfect. Okay.
I'm going to pull up lesson 2.
Okay. We have this tool called Applab, which is a JavaScript programming IDE that Baker described before. And we have a pretty strict philosophy in our early lessons for programming, where we really limit what students can see, so students can focus on the task at hand rather than having sort of the visual clutter of dealing with the whole IDE at their disposal. So we limit the things that they have access to early on so they can build their fundamental understanding of how programming works and how to structure their ideas in a programming language, and we increase in complexity from there. So this is the exact same sort of model we take or structure we took with understanding how the Internet works. Now we apply that same process of building up from the bottom. And Baker is going to show you what an early lesson, in fact the earliest Applab lesson, looks like.
So this is the screen for our programming unit, which if you are snooping around and poking at it, I want to put a huge caveat on the fact that this unit right now is the one that we are cranking on to get it done. It's going to see a lot of, if you click on anything one day, you shouldn't expect it to be there the next day. Also, don't, it's very drafty right now. So, all right, so if you've taught programming before or you haven't, the way that we start learning how to program is kind of a marriage of two well-known ways to teach beginning programmers. One is called Turtle Graphics, which was invented back in the 80s by a guy named Seymour Papert, whose life's mission was to get children to learn how to program. And we kind of merged that with another teaching strategy that I like, which is known as Carol or Carl the Robot. So in this lesson, students' first challenge is to get the little arrow to draw a square, but only using 4 commands. So I would say one huge difference about the way we teach programming in this course compared to others is that our fully fledged programming environment, or IDE, can be curated to single lessons and embedded in the lesson plan. So the way that I'm programming right here, I'm actually in our fully fledged programming environment. It's just curated for this particular lesson. So let me see if I can do it. Run. Great, I've got move forward and turn left. In our environment, you can copy and paste blocks. Reset and run. It shows it stepping through. The other interesting thing about our programming environment is that you can toggle it into text mode. We know that high school students really want, like, our view on the future is that a lot of students are going to arrive to high school having done a lot of block-based programming, and Applab was created to help solve the problem of the block-to-text transition. There's a similar tool out there called Pencil Code, which you may have seen, and actually we've collaborated with Pencil Code to use their block-to-text transition thing. So I can even type code here, and I can toggle back and forth. And an interesting problem that we've solved is you can type arbitrary JavaScript in here and toggle it back and forth between blocks. Let me just go to the next problem. So the next problem in talking about our methodology for teaching programming is to draw another square, but this time to go up and to the right instead. And if I'm limited to just these commands, in order to turn right, my only option is to turn left 3 times. And you might ask, why are we doing that? Why do we force students to do it this way? And the reason is that we want students to experience very early on the feeling of having to solve a problem given the constraints of the language that you're given. Because no matter how much you know how to program, you are always running up against the constraints of the language that's provided to you. You might have 2,000 commands at your disposal or 4, but the reason why you have to learn how to program is because you have to use those elements together. So we want to force students into solving problems given some limitations, because that allows us to open up more features of the language. So here, I've got a couple steps of it. After this lesson, you can ask students, hey, is there a command that you would really, really like to have? And they would really like to have turn right. And so it doesn't happen in this lesson, but in the next lesson, the first thing we do is they learn how to write a function. And call it, in which they are able to abstract out these elements of code that were repeated several times and to give a name. Sorry, I'm having trouble copying and pasting because I'm zoomed in so weirdly. We can give a name to a chunk of code that they want to use or repeat again. So we take a very functions early approach. They learn how to chain together function calls long before they even learn a loop in our strategy. And the other reason for that is because when we get out to building more applications, let me hold that point for a second. Our programming unit, so we start with these turtle graphics and learning the elements of the JavaScript programming language by building up all these lessons. And in our third unit, the culmination of the turtle graphics is for students to do a collaborative, we call it the digital scene project, in which students devise some sort of digital scene that they would like to convey that has some randomness to it. So if I run this again, you're going to see it'll be slightly different. There'll be fish in different places. The grass will be a little bit different. And each student, when they come together as a group, they take on a particular element of the scene. So one person is in charge of making the grass or the fish, or some might do a moonscape and they're in charge of the moon and the stars or whatever. You could invent any kind of digital scene. So each student takes on an element that they want to produce sort of randomly, and then they bring their code together to compose the final scene. And that's our first real collaborative project, which we want to do because in CS Principles you have to collaborate with other people to build a project and be able to reflect on that collaborative experience. So a digital scene like this is sort of the culmination of our turtle graphics before we transition into making, for lack of a better term, apps. One reason so what I'm showing you here is the full sort of open play Applab, which has many, many different commands you can use. And if you hover over a block, you can go. We've curated sort of our own documentation for all of these functions that's built in online. And again, you can always type anything. I'm going to make a little app here for you. I'm going to attempt to. I'm not sure if sound will come through. But let's see. So one thing that's interesting about Applab is there's a command here called button, and if I hit run, it puts a button on the screen. And if you have done programming before, what it's actually doing is dynamically with JavaScript, it's attaching an HTML button to the screen. For a button, if I want it to do anything, I have to add what's called an event handler. And this is why one of the reasons we learned functions early is because when you're doing event-driven programming, the sort of model that you have to get your mind into is my program is doing nothing at any point, and a user could do anything at any point in time, and I need to have a function at the ready to handle that event. So I'm going to attempt to play a sound. Where is that in here? Here it is. Play sound. You can put in an HTTP reference to some sound that exists on the internet, or you can upload your own assets. So I'm going to do this monster growl. So now if I run my program, if I hit could you guys hear that? All right, so
yes. We could hear it.
So so what's interesting is that with code we can add elements to the screen. I can add text inputs or drop-down boxes, and as I run that way, I can sort of dynamically attach elements to the HTML screen. What's really cool about Applab, though, is that once you've sort of gotten that down with code, we have this view called design mode. I'm going to reset here. It looks like I've got a... Also, the tool is in beta, so you might see like weird artifacts sometimes. Oh, come on now. We have a view called design mode, which is a WYSIWYG drag and drop editor. So I'm going to make the same program where I'll drag a button out. We have some styles sort of built in, but you can also you can also set your own style. So I could change the color of a button to be, you know, whatever I want here. And what it's doing behind the scenes actually is just changing the CSS that's on the CSS code for that HTML button. You can also attach an image to the button. So I'm going to upload a little picture of a kitty. So now I have a kitty button. Get that text off of there. And the other interesting thing about design mode is if I want something to happen when that image is clicked, I can attach the event dynamically right here in design mode. So it'll insert the code for me to handle that button. By default, it has a console log statement, but I'm going to take it out and I'm going to put my sound back. I think I have to re-upload it because I made a new project.
Everyone brace yourselves. If you're wearing headphones, hold them away from your ears for a moment.
All right, so here we go. Here's my cute little kitty, and I'll just click it. So you can do a lot of fun things pretty quickly with this tool, and it is actually quite powerful. One of its most powerful features is that we have backend data support. So this is a little app that I put together ahead of time, and I'm going to ask Jeff to be my participant. So this is an app I put together. It's actually a famous economics experiment called the Beauty Contest. And Jeff, in this experiment, you are supposed to, it's actually a contest to see how well you can predict what other people think. So let's see. I'm going to enter Jeff. I'm running the app here. I'm going to enter Jeff's name. All right, I'll just leave it at Jeff. And Jeff, what I want you to tell me is, of these three images, which one do you think most other people would say is the cutest?
Probably the baby.
That's a very good answer because that's a picture of my son. So so Jeff has entered his name and I chose the son. If I click submit, it takes me to a results screen. So in our apps you can make multiple screens. You can also, I made an app that shows you the results. It looks like my son is winning. That's really good. That's what the user would see, but you can see this little view data button here. if you click on View Data, you can go and look at your data table that's in the background. So this data table here, I can scroll down and I can see, oops, too far, I can see that Jeff did in fact choose the baby. What's interesting about this data table is obviously you can see, if you know what JSON is, it's constructed in JSON underneath the hood, but students don't actually have to know anything about JSON to construct these tables. I can add columns using this editor here. I can actually create the table in the first place. There is an import button right now, so you could import data from an Excel file or CSV file if you want to bring data into your app to start with. Pretty soon an export button is going to be there, so you can export your data that your app has collected and put it into some tool for analysis later. So having taught computer science for a long time and wanting to make apps like this, having cloud-based data storage that's really easily accessible and easy to add stuff to is, I think, an extremely powerful thing for students to have. But also potentially a dangerous thing, right? Like, and one of the things that we do in our data unit is talk about those social implications of having and collecting apps, or having apps that use and collect data. Brooke, do you have something to add?
Yeah, so why don't you share that app with me so that way I can ask all my friends who they think is cutest, or who they think other people will think is cutest.
Right, so I didn't show this feature, and the share, you can share this either with its link and it'll pull up in a web page. You can also send it directly to someone's phone. I'll just put in my phone number, or do you want me to actually reveal to everyone your phone number, Brooke?
Well, I don't care. No one call me.
I haven't memorized it. I'll just do my phone.
Okay, that's fine. Well, hold up your phone, though, so people can see it.
Right. So if I send it, oh. I don't know why it was an error. Did I type it wrong?
I don't know.
You can see
your phone number.
You can see this behavior. I think we should probably move on, actually. But you can see this behavior in, we have a tutorial video set up.
Yeah, and we will be linking to that tutorial video with the slides that we send you at the end of this. And actually, everyone, if you can see my phone right now, this is an example of what happens when someone shares a website or shares their project with you. You get a text message that takes you straight to Code Studio. I have a feeling this is a particularly lame app because I'm pretty sure I just did this to show someone how share works. It might just be like a single button that says click me or something like that. But it will open it in the browser of your choice, and it just runs the program automatically. So it shows up here. You can still do all of your kind of remix type of things and see the code, but it shows by default just that view screen. Okay, so I want to talk a little bit about where you can go from here, what you can do from here, and then I want to dive into some questions that I see folks coming in with. So let me share my screen. So we've got some slides for you at the end of this, and you can access this slide deck that I'm on right now at the bit.ly. Wow, this is wildly unresponsive. If you go to the bit.ly/CSP4HS-code.org. Oh no, I'm getting the loading screen of death that everyone was getting at CSTA. I will stop screen sharing, and Jeff and Deepa will add this link for you guys in the Piazza page. I don't know why Google presentations have been doing this, but in this Google presentation, there's a link to our syllabus. There's a link to a one-pager that tells you about our PD program. There's a link to the student and teacher-facing versions of Units 1 and 2 in Code Studio, and then there's also a link to the Applab Open IDE. So, Baker, if you want to go through questions, I've been adding a couple things in here to help address some of those questions. If you wanted to start with the question about the 4 units, and not all of the big ideas seem like they're represented in those 4 units. I added a shot of the 2D framework on slide 4 if you wanted to show people that.
Oh, okay.
Baker, can I go ahead and read out the question? And
wait,
then go right ahead.
Let me address the question that Brook just
Go right ahead. Thank you.
So I've lost my screen. So somebody asked, how do we think about the 7 big ideas in the course? And we do have a theory of action on this. And Brooke, what slide is it?
Slide number 4.
That's what I see on slide 4.
Whelp. You need to refresh your page. I'll share my screen maybe. One day we'll all learn how computers work.
There's some limitations to Google presentation. Great, I think I've got it here.
Yeah.
So our view on the CS Principles framework is that the 7 big ideas are not all topics of study. In fact, some we view as topics of study, and some are more like principles of computing. So we take the view that the internet, programming, and data are topics of study, and that the big ideas of creativity, abstraction, algorithms, and global impact are more like principles that go through all of those topics. So we say that we've covered the internet when we have talked about creativity in the internet, and we do that by having students invent protocols. When we talk about abstraction, protocols themselves are abstractions. When we talk about algorithms in the internet, such as routing and encryption, and when we talk about the global impacts of the internet, such as security, privacy, and hacking. And we have similar approaches for programming and data. And we know that we've covered abstraction, for example, when we've talked about abstractions in the internet, abstractions in programming, and abstractions in data. So we have this sort of 2-dimensional view of the CS Principles framework. So even though you don't see units of study after all of the big ideas, it's because many of the big ideas aren't actually, well, if you read the framework, you would see that all of the learning objectives, a learning objective in one big idea typically references something in another one of the big ideas. So you're kind of always in at least 2 places in the framework at the same time when you're doing any lesson. And so this is our view of how we've sort of made sense of that. So that's an answer to that question. Deepa, you want to start feeding us other questions?
Great. Oh, that was a fantastic table. Thank you, Brook and Baker. I think this is going to clarify a lot of questions for a lot of the teachers. Bill Baker asks, is the distance partnership required to get at the lessons and the curriculum? Or I think that has been answered, that it's available to everybody, yes?
Yeah, that's correct. So any teacher who wants to pick up these materials, either use the lesson plans or the tools, whatever you want to use, it's all available. Units 1 and 2 are pretty stable. I mean, they're still being piloted and they're still in beta, but they are in Code Studio right now in pretty close to the form that they'll stay in for pilot year. But as Baker mentioned, Unit 3 is still in a state of flux, and we're still getting everything into Code Studio. But feel free to use any of these materials.
You do need to have a teacher account to see the lesson plans. One thing we didn't show is that when you're in Code Studio, if you're logged in as a teacher, one, you see the lesson plan links, and also there's a teacher tab that if you pull it out, a sidebar, it would show you all of the students in your class. And if you're looking at like a free response question, it would show you how all of your students had responded. If you're looking at a programming level, it would show you all of the programs that your students had written for that. If you're looking, so the idea is that you go to the same place that the student goes, and you pull out your teacher tab, and you can see what they've got there. So you want that, obviously, as a teacher, but you do need a teacher account to see these courses and pull them up. One of the issues that we're trying to figure out is that because, unlike Code.org's other courses, which were mostly for smaller children, the ones that we've built in-house, an AP course lesson plan has answers and rubrics and things like that, and we need to verify that people are teachers who are getting access to some of these tools, and we're working on a strategy for that right now. Brooke also didn't mention Unit 4 is in much the state of Unit 3. We've just prioritized Unit 3 to get it done first for our pilot teachers, because they'll be getting to it sooner, and Unit 4 will be shortly behind it, probably a month behind that.
But that's fantastic. Thank you for letting us know about the teacher login. I think that's a great strategy you have in place. That's excellent. Nathaniel Norman asks if you can never keep us happy. Are the lessons available in other languages other than English?
Not right now.
But that's important. They're not yet.
Yes.
Hey, Google Translation does a great job.
And if Nathaniel or anyone else would like to start translating them, we would love that to happen. Keep in mind, all of our materials are totally open, so you can feel free to take them and remix them or translate them. That'd be great. But moving forward, that's definitely the type of thing we would be interested in.
I would say the one caveat is that our concept videos are closed captioned. In English, and will be closed captioned, if not already, in multiple languages. So at least all of our videos, we always do that.
That's fantastic. And to continue with Nathaniel's questions, I do thank you. Between the two of you, you have answered that we can get a teacher login or a student login, and that they are free for everyone. But the other concern or question is, will it be reasonably ready by the time 2015-2016 school year turns around? We are in July. Most schools in this side of the country, I live in Atlanta, start mid-August. But again, many schools start after Labor Day, giving us, to say there is a hope maybe that all the course will be complete and ready by the time the school year starts.
So right now, Unit 3 is scheduled. Our target is to land that by September 1st, so that Units 1, 2, and 3 would all be in place for the beginning of the school year. Again, Units 1 and 2 are ready to go now. You can look at them. That would get you. You would not start, if you are on the pace of our lessons, you would not start Unit 3 until December or January anyway, because it's halfway through the course. And Unit 4 is scheduled to land on October 1st. So yes, we would be putting lessons underneath your feet as you were teaching them. If you are a kind of person who needs the entire curriculum book approved or something before the school year starts, I guess I have to say, sorry, we're not going to have it. That is the timeline for development. But if you wanted to teach the course, there's plenty to go on right now to get you started, we think. And at least when we do professional development with teachers in the summer, we only cover elements from Units 1 and 2 because it's too much to take in to cover the whole course anyway. So really our timeline for development is in pace with our sort of official pilot instructors and what they need at the right time.
That sounds fantastic. And I do want to compliment you both on the fantastic share program that you showed us, how you could share. I'm going to confirm that once the app can be shared, a student should be able to take it and show it to their parents.
Absolutely, yeah.
Right.
Parents, friends, teachers, whomever.
Right. And that was, I think, one of our teachers were wondering, and that's fantastic. Very impressive set of tools, a very impressive presentation. It is certainly very apparent that you both have put a lot into even getting this out for our teachers, and Jeff and I greatly appreciate what you guys are doing. Thank you for your efforts, and Jeff, the floor is yours.
Okay, I think we were able to answer a lot of the questions, or maybe a few that we didn't get to, but we'll try to address those on Piazza later as much as we can. So I don't know, is there any final wrap-up you, Baker or Brooke, you'd like to offer? Any future words, or any other thing else about code.org that you might want to mention that's going on outside of CS Principles for folks who may not be all that familiar yet with some of the offerings?
Yeah, sure. Well, I'll start with CS Principles and say, please use our materials. Use as much or as little as you like, and then please do give us feedback on whatever you use. We hope that a lot of these things are generally useful, even if you're not choosing to teach our whole curriculum. So please use whatever you think is going to be helpful. In terms of general CS Principles stuff, if you are new to the CS teaching world, I would recommend you go to code.org/educate, and you can learn more about all of our programs, which start in elementary school and span all the way up through high school, and include things like Hour of Code, which are cool marketing and recruitment activities to get kids excited about computer science. So if you head over to code.org/educate, you can learn more about all of that. And if you ever have any questions about CS Principles, you can email us, and we would love to hear from you. And we'll make sure that Jeff has our emails in the Piazza group or over on the course page.
So a question just came in that we forgot to address. If you go to the /educate page, you will not see Unit 2 there yet. That's because everybody on this MOOC is special. Our courses right now are sort of hiding in plain sight. You need the direct links to them to be able to see them because they are in pilot mode and still in beta. And we're giving you're free to use them. I mean, it's not a secret that they're out, but in the presentation, in the links that Brook is providing to Jeff, we have direct links to those units in Code Studio.
And you will need to be logged in order to see that stuff. So you can go ahead and set up a teacher account. It doesn't cost anything, and it's not any harder than setting up a student account. Do that, and then you'll be able to see all of the lessons for Units 1 and 2 by following those direct links. And we are actually ramping up to put Unit 1 online very, very, very soon, and Unit 2 online not long after. So those will be like publicly viewable, not just sites that you hit with a specific link very soon.
Excellent. So thank you both for sharing everything and making the stuff available for all the teachers on our MOOC. And we've heard a lot of great things about the pixelization and the text compression tool. So thanks for sharing that. And we've had a lot of discussions and things like that around those tools. So I guess that wraps this session up, and we will be continuing any discussion on Piazza that anyone wants to follow through with. We thank again Baker and Brook for this, and we'll be archiving this for anyone who wants to come back and take a peek, and we'll also be posting the URLs that Brook and Baker provided to us. So thank you all, and we'll see you all again soon.
Thanks so much for having us. Bye-bye.